I'm going to go through review 1 for the perimeter and area unit. So for number 1, what is the area of a circle whose equation is that? Well, remember the area formula for a circle is just pi times the radius squared, so all I need to do is identify the radius here. I'm going to rearrange this a little bit so that I'm able to complete the square to more easily identify what the radius is. Right, so I need to get it in standard form. So if you remember, the process by which we do that is we look at the b term, the number next to the x and next to the y. I'm going to take half of 14, square it, and add it to both sides. Half of 14 is 7, 7 squared is 49. Half of negative 8 is negative 4, and when I square that I get 16. So when I add that to both sides, the right-hand side of my equation here is just 121, and I actually don't care what that left-hand side turns into, because that's just going to get me what the coordinates of my center are, but remember the end of that equation is just whatever my radius squared is. So really, this information alone tells me that my radius is 11, because that's the square root of 121. And if I plug into the area formula, pi r squared, that just means that the area is 121 pi, 11 squared times pi, or if you type that into your calculator and round it, you'd get about 380.13. And I don't know what the units are, so I'm just going to write units squared, because remember, if it's area, it should be some sort of square unit. For number 2, in the accompanying diagram of trapezoid ABCD, AB is 26, BC is 10, CD is 18, CB is perpendicular to AB, and altitude DE is drawn. And they want me to find the perimeter. Now notice you actually have 3 out of 4 sides, but you're missing this slanted side here of that right triangle on the left. Because remember, the perimeter is just the sum of all the sides around the edge of a figure. Well, I've got a right triangle here. I know that vertical piece is going to be 10 because the opposite side is 10 there. And I know from E to B is 18 units. And if the whole base on the bottom is 26, that must mean AE is 8. The reason that helps me is because this is a right triangle where I'm missing one side. So I could just use the Pythagorean Theorem to solve for my missing side there. So one of my legs squared plus my other leg squared is equal to my hypotenuse squared. 164 equals my hypotenuse squared. And to undo the squaring, I'm just going to take the square root. So that missing side length is just 164 under the radical. So that's not a perfect square, so I'm not going to round it. I'm just going to leave it as radical 164 until the end where I sum all the sides. So the distance around the shape is going to be that 26 on the bottom, the 10 going up, the 18, and then the radical 164. So I can express my perimeter as 18 plus 10 plus 26 plus radical 164, or 54 plus radical 164. Or again, if I type that into my calculator to get a rounded answer, because radical 164 is irrational, that's just going to be 66.81 units. Number 3, given AB equals 7, BC equals 24, what is the area of the shaded region to the nearest thousandth? Well, in my head here I see two figures. I see a circle and I see a triangle. So my goal here is going to be able to find the area of the circle, the big area, and subtract away the white part, the area of the triangle. So if I'm thinking, I know B should be a right angle because it's inscribed in a semicircle. Remember, any triangle inscribed in a semicircle, if it has that hypotenuse as a diameter, it's going to be a right angle there. So I could use a little bit of Pythagorean Theorem to find out the diameter AC. Because remember, the goal for finding the area of a circle should be to identify what the radius is. And if I know what the diameter is, I can just cut that in half. So let's start with some Pythagorean Theorem to solve for AC. 7 squared plus 24 squared equals x squared. 7 squared plus 24 squared is 625. And if I take the square root of that, I find that that hypotenuse is 25, or the radius, just half of that, should be half of 25, or just 12.5. So that helps me find the area of the circle, which would just be pi times the radius squared, or pi times 12.5 squared, or if I square 12.5 in my calculator, my area of the circle would just be 156.25 pi. So you can multiply out the pi in your calculator if you want to get the decimals here, but I always wait until the end to round my answer. So that's the area of the circle. The area of the triangle, remember the formula for that is just 1/2 the base times the height. And my base and my height are always perpendicular, so I can consider my base to be 24 and my height to be 7. So the area of the triangle would just be 84 units squared. So to find the area of the shaded region, I'm just going to take my big area, the area of the circle, and subtract away the area of the triangle. And if it says the nearest thousandth, then I want 3 decimal places, so it should be about 406.874 units squared for my shaded area. Number 4. An isosceles triangle shares its base with the diameter of a semicircle. The base angles of the isosceles triangle measure 70 degrees, and the diameter of the semicircle is 6 millimeters. Use trigonometry to find the height of the isosceles triangle. Round to the nearest tenth. Well, let's just take a look at one of these right triangles here. I know that's a right triangle because the altitude should be perpendicular to a base. And for an isosceles triangle, that altitude is going to split the base in half. So each of those pieces should be 3 millimeters long. I'm going to redraw this right triangle over here. So I've got a 70-degree angle. I'm looking for that side, and I know that piece is 3. So I'm going to write down SOHCAHTOA, and then I'm going to label my sides, because they're telling me to use some right triangle trigonometry. I know that 3 is adjacent to my 70 degrees, and that x is across from my angle, so that's my opposite side. So I don't know anything about my hypotenuse here, but the ratio that relates the opposite side to the adjacent side is going to be tangent. So I can set up the tangent of 70 degrees is equal to my opposite side, x, divided by my adjacent side, 3. If I put tangent of 70 over 1, I could cross multiply and solve that proportion. X times 1 is just x, and if I multiply 3 times tangent of 70 in my calculator, I find that that's about 8.2 millimeters, right? Because they say round to the nearest tenth, so I just want 1 decimal place. Now the reason why this is helpful is because if I now know the height, and I know the base of that isosceles triangle, that helps me get a little bit closer to finding the total area of the shape. So there's 2 shapes here. There's a triangle, and there's a semicircle. For the triangle, remember the formula is 1/2 base times the height. I know the base is 6, and we just found the height to be 8.2. So the area of that isosceles triangle on the bottom there is just 24.6 millimeters squared. For the semicircle, that's just half of a circle. So I know pi r squared would get me the area of a full circle, so if I multiply that by 1/2, I'd get the semicircle area. The only thing you need to identify is the radius, and if the diameter is 6, the radius would just be half of that, or 3 millimeters. So when I substitute in, I find that the area of my semicircle is just 9 over 2 pi. And I could slap a unit on the end of that too, but I'm going to do something with these before I add a unit to the end. If I'm finding the total area of the semicircle and the isosceles triangle, that's an addition problem. So I'm just going to sum those 2 values. So 24.6 plus 9 over 2 pi. And again, if you wanted to convert that to a decimal right here, you could. But if I type that all into my calculator at the end, I find that my total area is just 38.7 millimeters squared. So for the total area there, I just sum the 2 pieces that I see, a semicircle and an isosceles triangle. Number 5, given rectangle ABCD, where AB is twice the length of AD and the perimeter is 36 feet. Determine the area of the shaded region to the nearest hundredth of a square foot. Well, it says that AB is double AD, twice the length. So if I label AD as x, I could label AB as 2x, because that's twice the length, multiplying by 2. Now for a rectangle, remember opposite sides are equal, so I could label BC as x, and DC as 2x. And they tell me my perimeter is 36 feet. And remember, I get that just by summing all of my sides on the outside of a figure. So I'm going to create an equation to help me solve for x. 36 is equal to, well, I've got the two x's on, for AD and BC, plus 2x, my top side and my bottom side there. So that's the sum of all my sides. That should be equal to 36. Remember, when you're adding variables, you can just sum the coefficients as long as the exponent for the variables are the same. So 1x plus 1x plus 2x plus 2x makes 6 x's altogether. And if I divide out the 6, I find that x is equal to 6. So that just means that my length of AD is 6, and my length of AB is 12. So anytime I solve for a variable, I like to plug it back into my picture, just so it gives me a little bit more information. Now I want the area of the shaded region. So visually, what I'm going to think to myself is I'm going to find the area of the rectangle, the full area, and subtract away the area of the two circles, the white parts. So for the rectangle, remember the area of a rectangle is just base times height. And I know those two values already. It's just 6 times 12, or 72. For the area of the circles, if I find the area of one circle, it would just be pi r squared. Now remember, you need to identify the radius. But notice that this vertical piece right here should be the same as AD, and that represents a diameter. So if that diameter is 6, half of that for a radius would be 3. You can also make a horizontal argument that that should be 6 because it's half of the side AB 12. So again, if I cut that in half again, my radius is still 3 going that way. So the area of one of my circles is just going to be the radius squared. 3 squared is 9. So that's one of my circles. But if I double that, or multiply it by 2 because I have 2 white circles, I'll find that the area of both those circles is 18 pi. So for a final step for this shaded area, I'm going to take the area of the rectangle, 72, and subtract away the area of my circles, 18 pi. And when I do that in my calculator, I get about 15.45 feet squared, because it says to the nearest hundredth of a square root, so I should have 2 decimal places going there. For number 6, the length of a rectangle is 2 more than 3 times the width. I'm just going to sketch a picture there. So if I label the width as x, the length should be 2 more than, so plus 2, 3 times the width, so that's triple, multiplying by 3. And again, it tells me the perimeter is 60, and that's just summing all the sides. Remember that opposite sides in a rectangle are congruent, so I can set up the same sort of problem, where I set 60 equal to the sum of all these sides. So if I add up 3x plus 2, here's a shortcut I could do. 3x plus 1x is 4x, plus another 3x is 7x, plus one more x is going to be 8x. And then if I add my constants, 2 plus 2, that's just 4. To me, that's a little bit easier of an equation to look at there. Because to solve for x, I could just subtract away the 4, and then divide out the 8 to find that my value for x is 7, which means that my width is 7, and my length is 3 times 7, which is 21, plus 2 is 23. So if I'm finding the area, remember that's just base times height, so the area of that rectangle would just be 7 times 23, or 161 centimeters squared. Number 7. A baseball field can be represented by a sector of a circle with a central angle of 90 degrees. And the radius is 300 feet. So that straight side should be 300 feet, and that straight side should be 300 feet as well. A mysterious donor is going to pay to completely enclose the field with a fence. Determine how many feet of fencing will need to be purchased. Well, there's three parts of this sector, right? There's this straight side that's 300, so I'm going to need at least 300 there. There's this other straight side that's also 300, so I'll need 600 altogether for those straight sides. But I need to figure out how long the distance is along this curve part right there. So if I'm finding the distance along the curve part, that's a part of the circle's circumference. That's called the arc length. And we have a proportion we could set up to solve for the arc length. We could take the central angle, divide it by 360, and set that equal to my arc length, and divide it by the full circumference of my circle. Right? Remember, the circumference is just the distance around the circle, and we have a formula for that. It's just pi times my diameter. And in this case, if my radius is 300, my diameter is just double that. So I could represent my circumference as 600 pi. So I'm going to set up a proportion here. My central angle is 90 degrees, divided by a full rotation of a circle is 360, equals my arc length, which I don't know, divided by my full circumference, which I know is 600 pi. Now to solve any good proportion, I'm going to cross multiply. If I multiply 90 times 600 pi, you could just type that into your calculator if you want. I normally leave the pi until the end, so I just multiply the 90 and the 600 in my calculator to get 54,000 times pi, because I didn't type in pi to my calculator yet, and 360 times x is just 360x. Now to keep solving for x, I can divide away the 360, and when I type all of that into my calculator, because I know I'm going to need to round here, I find that that arc length is about 471.2 feet. Now, if I'm thinking about this realistically, I probably can't buy 1/10 of a foot of fencing, if I walk into a store. And the question's a little ambiguous, so it doesn't really matter, if you don't think to do this at this step. I'm going to round that up to 472 feet, because if I buy 471 feet, it's not going to be enough. So that's how much I'm going to need along that arc length there. But don't forget that you still have your 300 and 300 along those straight sides on the left and right. So altogether, I'm going to need about 1,072 feet of fencing. Now, let's say the fence cost $17.49 per foot. How much will the fence cost when I buy it for the entire baseball field? Well, that's the cost per foot. I can just take the cost per foot and multiply it by the number of feet that I'm going to need. And again, when I type that into my calculator, I find that the total price is $18,749.28. And remember, for money, we should always be rounding to 2 decimal places if we need to round it off. Number 8. Find the length of each arc. Round your answers to the nearest hundredth. Now, I'm just going to do A for both of these because A and B are very similar. It's just knowing the process. For the length of an arc, I'm going to take my central angle, divide it by 360, set that equal to my arc length over the total circumference. Remember, that's just pi times my diameter. Here it tells me my radius is 19, so my diameter must be double that, or 38. So that's going to be 38 pi. Again, if I cross multiply, if I do 38 pi in that denominator, multiply it by 150. 150 times 38 is 5,700. You can multiply out the pi if you want to, because we're going to have to round anyway, but it doesn't matter at this point. I'm going to divide out the 360. And then I'm just going to type this straight into my calculator and round it to the nearest hundredth, so 2 decimal places. So my arc length is about 49.7 feet. So what we just calculated is the distance from there to there if I were to walk along the edge of a circle. So that's some portion of their circumference. Part B is the exact same process. I want you to check the answer key on Google Classroom to see if you got the same answer as me. For number 9, it's a very similar process. I'm going to take the central angle, divide it by 360, and set that equal to my area of the sector now over the total area of the circle. That's what goes in that denominator right there. Remember, the formula for the area of a circle is pi r squared. So in this case, that's just going to be pi times my radius squared, or just 121 pi. So that's what I'm going to put in that denominator there. Again, I'm going to cross multiply. 315 times 121 is 38,115. Again, if you want to multiply the pi and have all those decimals there, be my guest, because we're going to have to round anyway. But to me, it's easier to just write it in terms of pi, and then type it all into my calculator at the end. So when I type that all into my calculator, I just get 332.62 feet squared, because it's an area. So what we did is we just calculated that area right there made by the central angle of 315 degrees. Now number 10 is a little bit different based off of the information we're given, but we could still use a similar process. In the diagram below of circle O, the area of the shaded sector AOC is 12 pi. The length of my radius is 6. And they want me to determine the measure of that central angle there. Well, remember the formula is just the central angle divided by 360 equals the area of the sector over the full area of the circle. And I know the area of the sector. They told me that's 12 pi. I could figure out the area of the circle because that's just pi times my radius squared. And the only thing I don't know is the central angle. So all that changes here is where my variable is. So the central angle I'm going to label as x, I don't know that, over 360 equals the area of my sector, 12 pi, over pi times my radius squared. And my radius squared is just 36. So that's the proportion I'm going to solve. Now if I wanted to, I could cross multiply from here and go to town, but I actually noticed that there's some things I could do to reduce here. Pi divided by pi is just 1, because anything divided by itself is 1. And if I divide 12 by 12, I get 1. And if I divide 36 by 12, I get 3. So if I wanted to reduce this before I start multiplying across, these equations are equivalent. And the reason I might recommend simplifying to the bottom one is just to make the calculations when you type them into your calculator a little bit easier. Because now when I multiply across, 3 times x is just 3x, and 1 times 360 is just 360. And if I divide out the 3, I find that my central angle that I'm missing is 120 degrees. And it's not always drawn to scale, but if I'm trying to visualize this, that looks like it's an obtuse angle. It's not quite 180, so it makes sense that that could be 120 degrees. Number 11. What is the area of a sector of a circle with a radius of 8 inches formed by a central angle that measures 60 degrees? Well, remember it's central angle over 360 equals the area of the sector over the full area of my circle, which remember is just pi r squared. In this case, it's pi times 8 squared, and 8 squared is 64. Now there's one thing I want you to notice here. My answer choices are all in terms of pi. So I'm not going to multiply out the pi in my calculator, just because I want to still have pi in my answer when I'm done. So if I just multiply 60 times 64 in my calculator, 60 times 64 is 3,840, but I'm still multiplying by pi. And 360 times x is just 360x. I'm still going to divide out the 360. But when I type this into my calculator, I'm just going to type in 3,840 divided by 360. And when I do that, you'll notice you get a decimal that looks like this. You get x equals, and it's like 10.6 repeating times pi. That's not really helpful to us, but what we could do if we really wanted to, we could type this in and make it a decimal and then make all those answer choices decimals and see which one matches up. Or you could just reduce this fraction in your calculator. And the way to do that is to hit the math button, which is right below alpha, then hit the enter button, and then one more time hit the enter button. And what that's going to do is that's going to change that fraction from 10.666666 to 32 over 3 as a reduced fraction. And I'm still multiplying by pi. So my final answer would be 32 pi over 3 if I reduce that fraction in my calculator. You don't have to, you could convert all those to decimals, but that's probably the easiest and fastest way to do it. Number 12. In a circle whose diameter is 32, the area of a sector is 171 pi. Determine the measure of a central angle of the sector, and it should be the closest to one of these. Again, central angle over 360 is equal to the area of the sector over the full area of the circle, which is pi r squared. Now notice we were given a diameter of 32, which means my radius is half of that, 16. So that's the number I'm going to square when I plug into pi r squared. And 16 pi is just 256. Again, if I'm dividing pi by pi, it might be easier just to reduce that there. If I cross multiply, 256x equals 61,560. And if I divide out the 256, you'll find that x is about 240 degrees. Number 13. Given a triangle with vertices 1, 0, 5, 7, and negative 5, 4, calculate the area of ABC. Well, the first thing I'm going to do is plot this triangle. So I took a sec to plot that triangle, and notice I connected all of my sides with a straight edge. Now, normally for the area, we would just do 1/2 the base times the height, but since this figure is slanted, that's kind of hard to do. So the strategy here is to box the figure in so we can find the shaded area and subtract away. So I'm actually going to make it so that I draw a rectangle around my triangle so that it's perfectly encased, so that all the vertices of the triangle touch the edge of the rectangle. So it should look something like this. That's what I'm doing in purple there. And notice I've created 3 right triangles around this figure. There's this one up top that I'll shade in to the best of my abilities. It's not going to be perfect, but you'll get the idea. There's this one on the left-hand side. And there's this one on the right as well. Now, I can find the area of those triangles because they're right triangles, and the base and the height are just vertical and horizontal pieces. I'm going to label that as 1, 2, and 3. So the strategy here is going to be to find the area of the total rectangle. I'm going to call that the box, length times width, and subtract away the sum of the triangles around it. And if I do that, I'll just be left with that white space in the middle, which is exactly what I'm looking for. So for the area of triangle 1, that's just going to be 1/2 the base times the height. And if I count boxes here, that base is 10, and the height going down is 3 units. So that's 1/2 3 times 10, or 1/2 of 30, which is 15. The area of my second triangle, if I count the boxes, that height is 7, and the base is 4 down there, and I'm just getting that from counting those boxes. 1/2 of 4 is 2. 2 times 7 is 14. And the area of the third triangle, the base is 6, and the height is 4. So 1/2 of 6 times 4, which is just 12. So the area of all 3 of these triangles combined, if I add 15 plus 14 plus 12, is just 41 units. So that's the area of the triangles in purple going around. The area of the box that I've encased my triangle in is just the length times the width, or just 10 times 7, which in this case is 70. So I'm going to take the area of my box and subtract away the areas of the triangles along the outside to find that my total area of the white stuff in the middle, which is the triangle I was looking for in the first place, is 29 units squared. So whether this is a slanted rectangle, a triangle, or whatever shape this is, I can always encase it in a rectangle so that I can just count the boxes to find the area.